Hello YouTube, my name's Dave. Welcome to my workshop in a single car garage here in South Australia. Come on in and let's see what we can make. Hello ladies and gentlemen and welcome. I'm Dave and I shall be today's tour guide of this long awaited shop tour. The tour will consist of starting at the front of the garage by the panel door on the right hand side and slowly working our way up the right hand side till we reach the top. We'll cross over the back of the garage and then work our way back down towards the door. We should be stopping at each machine in turn and giving a detailed chat and general views of the machine. Now the tour is a non-smoking tour, and please turn off your mobile phone so I don't get interrupted during it. For those of you wearing thick overcoats, there's no need, as the workshop is fully air conditioned, kept at a constant 25 degrees centigrade, 24 hours a day, 7 days. Now unfortunately I live very near a local airport, and today there's a lot of pilot training going on, so every now and again you might hear the planes buzzing over. Sorry about that. Actually I should have done it yesterday, because yesterday was a public holiday and there was no flying allowed at all, so we just had to put up. Now most of these shots will be handheld, because yeah, it's very difficult to try and get a tripod into the right position, so bear with me. I'll do the best I can so that you don't get screwy eyeballs. So let's now adjourn to the start, and we'll begin the tour. See you there. So here we are right at the start, and what you're looking at is my Taiwanese clone of a Bridgeport, purchased new about 3 years ago, 11,000 Australian dollars. I'll now move around a bit. Now in this cardboard box that you can see here, this is a tilting angle table, a recent purchase, and below it, under the black cover, is a foot operated hydraulic scissors lift, which contains a 12-inch box angle plate and an 11-inch precision rotary table. In use it will be pumped up as high as it goes, and then we can adjust the height of the knee and the table position to slide it on, so there's no lifting involved. I shan't be showing this today because it's quite a lot to get it all out, but there's certainly plenty of photographs at the end of showing how it all works. Now this machine is a single phase 20 amps V-belt drive head with an international 30 taper. It came as standard with the standard table drive and a 3-axis DRO, but only 2 glass scales of 5 micron on the X and the Y. As you can make out, hopefully, just there, yes, I've removed the standard 1-arm bandit handle and replaced it with a stainless steel. This machine, by the way, is a 10-inch by 50-inch table with metric lead screws. Now once the warranty, the 1-year warranty was out, I purchased an identical table drive, so that I've now got saddle drive Y-axis. Still manual on the knee, although when I do need to do a lot of winding, I've manufactured an adapter that fits onto the shaft with some pegs on it that drives in the castellations, and use a battery handrail. As the machine didn't have a Z-axis, I purchased a separate DRO from the USA and bought magnetic scales, one here which is on the quill, and the other one is on the knee, as I say, and the other DRO is actually mounted up there. Now another feature that I've modified was the if we can get in there, is the can we see it in the gloom? No, not really. Let's try looking from the other side. Yes, that's a bit better. I removed the standard threaded nut, and this what you're looking at here is a speed nut. can actually just push the button, immediately slide that to where you want it, and you've still got the facility of rotating it for fine adjustment. See it advertised on eBay in the USA, very reasonably priced, but of course it was megabucks for postage. So you know, I took a few measurements and away we go. So I say it's just a case of pushing this button there, releases the thread, slide it to where you want. If you want a fine adjustment, just rotate it around, no problems at all. Now the machine came fitted with a standard halogen lamp work light. Cool, does use that one. But I also purchased again from the USA a hound dog machining ring light, which has also got this extra little gubbins on the back, which is very handy for shining down holes. Now, as is standard on Bridgeports, this is a brake mechanism on the top that you can operate for stopping the spindle quickly, and also it should lock, allowing you to remove the tooling, but it's never worked. As I say, I'm a accredited machine tool fitter, or millwright, some people know it, and I fiddled with it for hours, and there's no way that I could get it to work. So what I actually did was a copy of what Mr. Pete in the USA did. Because quite often, you know, you really need three hands for tool change. You know, you've got to put the lock on, then you've got to undo the top, and you've got to hold the tool at the bottom, make sure it doesn't come crashing out. So what he did was he actually fitted a foot pedal, which actually operated down at the top, and it worked. You know, and he could you know, manage to take the tool out just with two hands. But what I did, I'd done it slightly different with that. I didn't want to, you know, try and wobble on one leg and trying to do it out. So what I've actually done is, and I'll pan down to here, is that I've made a handbrake assembly here. You know, it just operates. You know, if I pan up again, as I move the lever here, it's moving the brake lever up there, and I've actually fitted a pin, locking pin, so that I can just push that to there and it locks. And now the spindle is actually in the lock position. Works great. The biggest problem I get is every now and again is I forgot that it's that the brake's on. I've got to start the machine up, and of course the belts scream their heads off, something chronic. But you know, we're slowly getting there. The same, just a case of push that down, yeah, and it's released. Certainly, that was certainly one of my better ideas. Now moving on, lads, please put a bit of protection on your table. Look, piece of timber, piece of cardboard, piece of carpet, whatever. You know, I used to write and tell you, you know, when I used to see you putting spanners and things on your table, that, you know, really you're putting micro dings into it. You know, though you can't see it, in effect, you know, oh, I mean, look at that, 3 years old, just like the day it come out the factory, not a bloody ding on it. As I say, there's a board that I have on the other end as well. As you see, we've got you know, got the spanners and whatever it was in there. You know, no problem at all. Now, some of you might be wondering, why have I got two vices on here? Well, there's two reasons for that. Firstly, this one is my dry day vice, and this one is my wet day vice. So the reason being is the machine, and as the table is set now, I can only just get the door down. So it needs to be a dry day so that I can wind the table out and use it. And this one, of course, I can actually use with when the door's shut down. The other reason, the second reason for it is tableware. You know, most people stick the vice in the middle of the table, and that's where all the bloody wear is. Whereas at least this way, you know, I have to wind the table that way to use this one, and at the end of the day I have to wind it back in again to shut the door down. So, you know, it evens out the wear. In fact, Joe Piesinski in the USA, on his Bridgeport, he keeps the vice on one end and a rotary table on the other, because he does a lot of rotary table work, so of course he doesn't have to keep lifting it on and off, and it's already set up and he knows where the centre is and everything, so that's the reason for that. Now I suppose I better give you a quick bit of it running. There we are, that's running on there, and if I pan round a bit to where the brake is, I'm having to do this because I'm handheld. Stop it, operate the brake. Great. Right, and I suppose the other thing is I better show you the power feed as well. I mean it's only the standard what anybody else's milling machine has got. As I say, it's variable speed. Or rapid, and as we can see, it's heading out towards the out the door. I'll just stop that. Right, so there we are. I think that really I've really shown you everything that I can think of. So what we need to do now is to do a good 2 paces to the left, and that will take us up to machine number 2, which is my Tom Senior Junior Universal Milling Machine. So here we go, just follow along and see you there. Well, hello again. Before moving on to machine number 2, I suddenly realised that some of you may get a bit confused a bit later on as the tour progresses, as to wondering why I have so much English machinery. Well, the reason is I was born in London, England, and worked and lived there until 2006 when I came to Australia. I became a temporary resident in 2007, and then in 2019 I became a permanent resident, and as from the 12th of November 2021 I'm now an Australian citizen. So I just thought that I'd clear that little matter up. So without further ado, let us go back out to the workshop and look at machine number 2, my Tom Senior Junior Universal Milling Machine. Let's see you there. Now this is machine number 2, which is a Tom Senior Universal Milling Machine. Now this is highly modified. It didn't come like this from the factory. I'll put a picture up on that. Now the table is 6x24 imperial lead screws. The spindle is a number 2 Morse taper, and the whole thing is belt driven with back gear. I bought the thing new in about 1980 some odd, and had it delivered to the to Phillips where I worked, and did the modifications there. As we can see, there's a 3-axis Phillips digital readout, which is glass scales. Let me make that out alongside the spanners. Yes, that's a different type of method. It's an actual the graticals are actually printed on the glass, and it's you know, it works a bit different than the conventional ones. This is a high-speed head that I acquired from Phillips again, which normally fits an A Sierra FC3, and also the block that it is on is a riser block that I built. This hole that you can actually see there, that is the main spindle, whereas normally where the cutter arbor goes. And also I purchased a vertical milling head, which fitted in the same thing, but as you will see in a photograph, with the head on there and a cutter, I can only machine something probably about not much more about ½ an inch thick when it's bolted direct to the table, so it was totally useless. So I manufactured this up. What you're actually seeing inside there is that, and then, again there'll be photographs of this later, is I made up a drive pulley, which is the timing belt, which is driven off the main motor spindle, and then the belt goes up inside, and there's another bearing assembly inside there for driving the head. I mean, the main reason I went for this vertical head too was because it gives me a drilling function, and also I'm able to rotate it, you know, should I need to drill holes at 45 degrees or whatever. Standard W20 collets. I also this is the main machine is that drives this spindle is single phase belt driven, but the high speed head has got a 3-phase motor on the top. So, and I then decided to have a go at fitting a VFD on it. Not terribly successful, you know, what with all the different settings and things. As I say, my Bridgeport clone arrived, so of course, you know, this is now sitting here redundant at the moment. So now the other options that I fitted while I was actually at it was to put on a table drive. So round the side there is a where are we? Oh yeah, there we are. That's let's make it out in the gloom. That's a control box. Originally, it had a when I first done it, I used a Parvalux motor with a gearbox on, driving another cop variator and a flexible drive with a magnetic clutch. But so once I arrived to Australia, I've actually now fitted it with a forward windscreen wiper motor. If I push the button, we can actually see the. There we are. So there's the table drive going round, and of course I can twiddle the knob and change the speed. And the motor that's driving this is up the other end, under this black cover. And if I bob down a bit, you might be able to see it. There we are. There's a forward windscreen wiper motor, and there's the original gearbox. I kept that in circuit because it saved a lot of remachining problems. I've also then fitted a what's the word? Telcommit central lubrication system, so we can actually pump it on there, and all these little black pipes and things go to all the different bits and pieces. Right, so there we are. So what else can I tell you about it? Whoops! I better tell you what. I better just turn off this. As we can see, it's getting pretty close to the other machine. So it has got limit switch on it, but I thought, well, we better just turn it off while we're there. As I say, a great machine. Loads and loads of work done on it. So as I say, I wouldn't part with it because you never know when you know, if the other machine breaks down. And also, of course, this is actually a horizontal machine. I mean, I could set it up permanently horizontally, you know, put side and face cutters or gear cutters on and things. But yeah, so there we are. That's that little a machine. So from here we need to take 2 paces to the left, or maybe 3, and we'll come to machine number 3, and we will meet you there. Sorry, I forgot to actually show you it running. This is the main motor, which is in the inside the cabinet down here. So if I turn that on there, and that's the main spindle that's running. If I move around to here, I'll switch the high-speed head on. So this is a 2-speed switch. Here's we're running at there, or I can put it on the other arm. As I say, I did want to put this on a VFD, but I couldn't get it to work satisfactorily, so I put that on hold, especially as the other minute machine arrived. Now, I'm sorry to interrupt this tour again, but I just felt that some of you may be interested to hear the story of how and why I actually got hold of the Granville lathe. if it's not up to what you want, well, just hit the fast forward button. I started senior school in England in 1961, and I had the option of either woodwork or metalwork as a subject. So of course I picked metalwork. It was only a small shop. There was a couple of bench drills, a hand shaper, and 2 Boxford AUs, and the Granville lathe, quite a few workbenches, and a small forge. So I was got quite happy with that. I happened to go into the class a couple of years later, one day, and lo and behold, the Granville was gone, and in its place was a Raglan 5-inch vari-speed lathe. I got on well with the metalwork master. I mean, not wishing to boast, but he considered me one of his better students. I mean, most of the other lads it was just a muck about, really, a couple of hours a week. I mean, to be honest, I expect they would have rather been outside bloody playing football. Anyway, so I said to him, what's happened to the Granville then? He said, oh, it's in storage in one of the other rooms. So I sort of said to him, well, any chance I can have it? Oh, he said, I can't give it to you, but he said, I can sell it to you for £1. That's a UK, that's an English pound. Now, back in 1963, £1 was quite a bit of money. I mean, my father was a skilled tool room miller, and he was only on about £9 a week, so £1 was quite a bit. I mean, he used to give me 2 shillings a week pocket money, and at the time there was 20 shillings to £1, so that pound was 10 weeks pocket money to me. Anyway, so I said, yeah, fine, so we went up to the office and got the secretary just to scribble a receipt. This is what it was about. Now, bear in mind, I mean, it wasn't just the lathe. I mean, the lathe came with a faceplate, a catch plate, drive dogs, centres, 3-jaw chuck with inside and outside jaws, 4-jaw independent, and a full set of screw cutting gears, including the 127 that you need for cutting metric threads. So I thought, wow, that's a bargain. Now, I only lived about 300 yards away from the school. It was it was in the next street, and as luck would have it, one of the woodwork masters also lived in the same street, a few doors up from me, and he had an Austin minivan. So I twisted his arm, and we duly loaded it into the back of his little minivan, and he took it home for me. So once I got it home, I mean, it needed a little bit of a clean up, there was swarping all the gears and all that. Anyway, so I cleaned it all up and assembled it, and I thought, well, away we go. That's when I discovered that the electric motor was missing. So I thought, oh, lovely, what am I going to do now? Back in those days, Hoover up in Cambuslang in Scotland made industrial motors. They didn't only the company didn't only make washing machines and vacuum cleaners and things. So yeah, industrial motors. So I got the master to the metal master to write a letter on my behalf to, on the school note paper saying, look, one of my students has recently acquired this lathe. Any chance that you've got a second-hand one that you could let him have? Got a nice letter back, within a few days, saying, well, terribly sorry, no, we don't deal in second-hand, but as a special favour, for £10, we will send you a brand new 1425 RPM half horsepower capacitor start motor for £10. So of course, £10 anyway. But luckily, dear good old Dad, he gave me a cheque. Like I was saying, I mean, £10 to him, that was over a week's wages. But anyway, he duly gave me a cheque, and we posted it off, and within a couple of weeks, you know, the brand new motor arrived, which was duly fitted, and away we went. I started as an apprentice at Philips. I mean, at the time it was Mallard, but the Mallard Radio Valve Company. But Philips, the parent company, they bought them out, and you know, and the name was changed to Philips Research. As I say, I started there in 1966, two-year apprenticeship, and then of course progressed out into the workshop. Now, at the time, all the machinery was painted in company colours. The main body of the machine was a sort of an off-white. Any inspection panels, doors, drawers, whatever, were painted in blue, and then any handles and operating levers were painted in yellow. So of course I managed to scrounge a can of blue paint, and actually in due course I you know, took it home and painted my grey Granville, as it come from the school, to Philips blue. And in fact, over a period of time, as you'll see when we go outside in a minute, you know, I managed to scrounge all sorts of different bits and pieces and do various modifications to it. So hope you like that little chat. So without further ado, let us adjourn back out to the garage and actually see the Granville 3.5-inch gap bed lathe in all its glory. So let's go outside there now, and I'll see you there. So here we have my English-made Granville lathe, 3.5-inch gap bed, very very similar to a Myford. As you can see, as I described earlier, the blue paint has now turned a bit green, although along here I did manage to find in the drawer the screw threading dial that I've never used, and as you can see, that is a much brighter blue than how the paint's turned out. Now this is a plain spindle, number 2 Morse taper, a 1-inch 8 threaded spindle. It's V-belt driven, 3-speed with back gear. The cross slide has got T-slots in it for vertical milling. I've done vertical milling on here, as well as line boring. I built myself a 3.5-inch gauge locomotive and line bored the cylinders on here. The lead screws are 1/8 pitch, that's 125 thous per turn, and this is the replacement tailstock that I fitted. It's up a Myford ML7. Everything Myford fits this. The only thing that I had to do with this was to just to skim the base slightly, because it's a little bit above centre. As is typical with these lathes, there's no power feed. You put the finest gears on that you can on the change set, and you have to put up with it. So of course you couldn't change the spindle speed compared to the feed. So what I actually did was, when I actually ended up at when I started work at Philips, of course I could acquire a lot more stuff. You know, like to say, the paint. I also then got hold of contactors and fitted those, so it now has forward and reverse. And also I added, you can see in the gloom underneath, there's a small motor there and gearbox, and down amongst the other gloom is what they call a cock variator. You turn that knob and you can actually change the speed. It's done with a load of ball bearings. As you wind it, it changes the speed, and there's a small poly V pulley on the bottom there that then come up to one that I fitted on the end of the lead screw. Now unfortunately I can't show you this working at the moment because as I say, when I bought the other milling machine I've had to juggle everything up, you know, as tight as I can, and as you can see there's no way that I can actually put the belt on. Now at either end I've fitted a stop button which is at knee height. There's one at this end and there's one at the other end. Excuse the gas cylinders there, but as I say, short for space. So at least when I was working, you know, if I got caught up, you know, I could just immediately knock it with my knee and the power would go off. Now I've just removed the cover to show you the V-belts and things. Now if you're watching this, John, up in Scotland, I'm just going to run this for you so you can see what a Hoover motor sounds like that you've also got on your recently acquired shaper. So we'll now start her up. As you see, nice quiet motor, lovely machine. I've really enjoyed using it. Just turn that off. Oh, right. Yeah, so as I said, I certainly wouldn't get rid of it, as I say, for two reasons. It's sentimental value, and also you never know when you need another one. I mean, my bigger machine, I had a problem with the drivetrain, and I actually needed to machine up some bushes for it. So, you know, without a second lathe, you know, you've got to rely on, you know, a friend or whatever. As we can see here, it's got a genuine a Swiss-made multi-quick tool pulse over on there, and also down below there, that is a homemade carriage stop, just a brass block that's pinched on there, and of course I can just screw the micrometer in and out to a known depth, and away we go. So there we are. I hope you've you know, get a bit of interest out of it. I'm certainly pleased with it. It's so with this machine and together with my Tom Senior Miller machine, as I say, I've manufactured quite a lot of stuff, and in fact the last thing that I actually used this for was actually making my Caribou, which is 3.5 inch live steam loco. Right, so that concludes this little bit. So what we need to do now is to take 3 sideways faces to the left, and that will take us up to machine number 4. So we will meet you there in a short while. Hello again. Now this is the final interrupt of this tour. Scouts Honour, dib 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 dib. I just thought that you may be interested to hear the story of the Hardinge HLV, and you know how and why that I've got it. But say if it's not up to your liking, just hit the fast forward button and take it from there. Right, now as far as I know, this machine was made under licence in Exeter in England in 1955. It also had a special option fitted to it, which is a low speed drive. I've never managed to see, I've researched the internet, but I've never managed to see another one like it. The machine's got a 2-speed motor in it, and it goes from, I think 136 I think is the lowest RPM, but by engaging this low mechanism, and I thought it was a gearbox, when I opened it up, it's a couple of timing belts on a counter shaft anyway. So by flipping that over to there, you can get it down to 40, which is you know, quite useful. Now back then the workshop had dedicated turners, dedicated millers, jig bore specialists and all that type of thing. So this machine was bought as a brand new machine for one of the turners. It's Imperial, and it's what I know, and probably a lot of people know, as a direct dial. The lead through is 100th hour pitch, but the dial is actually marked up in 200, so you haven't got to fuss about with all this divide by 2 lark. So you know, if you're training something, you mark it up and it needs 70th hour off, well you just put 70th hour on the dial, you don't have to, you know, divide it by 2. So that's a nice useful feature. And also the other thing is too, the cross slide and carriage feed is done by a DC electric motor and variac, and it's got a couple of built-in cone clutches. Now the gearing in the carriage apron was so worked out that if you operated the cross slide and the carriage at the same time, it would give a perfect 45-degree angle. No idea, I suppose. Right, now moving on to about 1972. By then I was at my apprenticeship, and I was actually then a qualified machine tool fitter, or as some people know it, as a millwright. And the company also decided to standardise on making every machine metric. So of course, you know, lead screws and dowels had to be ordered what were available. And it was my job to Joe Muggins to go around there and to fit them all. Now the Hardinge, the option available for the cross slide was a 2mm pitch, so it was just a case of changing the lead screw and nut and keeping the original 200 thou dial, which then became 2mm. But of course, by doing that, of course, you know, you've turned it into one of these, you know, you've turned it into a radius lathe instead of a diameter. So all this, you know, you measure up and divide everything by 2 again. So, and of course, the automatic 45-degree function no longer worked because, you know, because the ratios weren't right. Now shifting on to 1985. Now the machine was starting to show its age by then. Now the workshop had a huge maintenance budget, and it had quite a reasonable new machine budget as well. But they wanted to buy you know, some other machine, and they thought, well, you know, they couldn't justify spending, you know, they'd rather have the new machine than the new Hardinge. So of course they sent the Hardinge away to a local specialist, and it was all re-garrons and new screws and new paintwork and new belts, etc. And say, come back looking like new. Unfortunately, they decided on the strip down, and rewiring as well, because they, you know, because it was the original 1950s wiring, so all that was modernised. In their infinite wisdom, they decided, oh well, we don't need this bloody back gear thing anymore, so they removed it. But you know, so the guy was happy, because I don't think that you know, he used it much. We now move on to about 1993, and the company decided that there was too many people working there, so they decided to offer all the over 55s a nice redundancy package to up and go if you want. So of course a lot of people went for that, and particularly the guy that used to work this lathe. I mean, you couldn't get out the door quick enough. So of course after a while the company then said, well, wait a minute, you know, you've got a big area here, all these machines, you don't need all these machines for the few people that were left. So they decided, well, you know, they you know, get rid of the ones that aren't used. So those of us that were left, you know, went round and had a chat amongst ourselves, well, let's keep this one, let's get rid of that one, blah blah blah, and a list was made. Now, because a lot of these machines were, say, in the 1950s, 1960s, though they were on the company inventory, they weren't worth anything to the company, so they generously decided to say, well, okay, they'll write them off. And we had quite an active sports and social club, so they gave the rights to the club secretary, and it was up to him. He used to put a notice up on the board, you know, anybody want a lathe, want a mill, you know, contact me, arrange a price, blah blah blah, etc. So I rushed over to see him. Of course, I knew the guy very well, because I helped him out with the children's Christmas parties anyway. So I told him I was interested in the Hardinge. He'd come over and had a look. He said, oh yeah, it looks very nice. You know, hope you can make good use of it. How much are you offering me? So I thought, well, you know, it's really worth quite a lot of money. But I said, oh, £60. And he went, oh, I don't know if we want to muck about with odd amounts. And I thought, oh, here we go, it's going to be 100. And he said, oh, £50. So he couldn't get my money out quick enough. So so that was, so the paperwork was all arranged for that. It sat there for quite a while, because I had nowhere to put it at home. I mean, I needed to put a new concrete base down, you know, because the thing weighs, I don't know, 3/4 ton or whatever, and build a new shed. So of course the lathe had to go in position, and then of course we then put the walls of the shed up around it. But in the meantime, I made sure that everything that I could get for it was there. So I said it's got a full set of imperial collets going up in 30 seconds, full range of millimetre collets up to 27mm in 1mm steps. Of course, all the other machines that were going, of course, we never let them go with all these, you know, with the Swiss multi-fix tool posts. I took all those off and I kept them in my spares cupboard. You know, so if anybody wanted a lathe, it went out with the lantern type tool post or a Dixon or whatever else on there. So of course I made sure I got a good stock of tool holders. So you never have enough tool holders, can you? But so when the lathe came with a face plate, catch plate, live and dead centres, drive dogs, 2 3-jaw chucks, a 4-jaw self-centering, a 4-jaw independent, every gear cutting gear that was available, because the guy ordered every one that was available so that he could cut any thread anybody ever asked him to, and a factory radius turning attachment. I'll actually put a video up on that somewhere, you know, to show you how all that works. So there we are. So as I said, I eventually, when the shed was done, I took it home, put it in position. Now of course England, the houses, well, our house certainly didn't have 3 bays, so of course I had to buy one of these converters. I bought a trans wave converter, the same one that you've got there, John, up in Scotland. And as you well know, they don't like running a 2-pole motor, so of course I could never bang it from high to low without the poor old trans wave throwing a wobbly. The other thing is too, I wasn't keen on metric. I hate working in metric, so I contacted a machine tool repair place down in Exeter in Devon, and they had some imperial lead screws and dials. So of course I then put it back to direct reading imperial, and now of course, not that I've used it, of course it now turns a perfect 45 degrees in where you've got both clutches. I think that's about it really. I think enough of my waffle. Let's adjourn outside and see the beast in all its glory, and you know, I'll meet you there. Bye for now. So here we see my Hardinge HLV lathe in all its glory. Let's move you in and show you some of the other features that we've got. It's a 3-phase machine with a 2-speed motor and variable drive. I'll run it for you in a minute. It has the standard, it's 5C collets, and it also has the standard Hardinge 4-degree, oh, he's turned it round, 4-degree chuck taper. The idea is that when you put the chuck on, it's got in this slot here. When you put the chuck on, jam it onto the, turn it to fully clockwise for forward running, and move it fully anti-clockwise if you want to do reverse running. I'll give you a little run of it, and by winding this handle here we can increase the spindle speed. That's in low. It goes from 125 to 1000 in low, or if I flick this lever here, put it into the high range, it then goes 375 to 3000. And what's nice about it is, of course, you know, you can, while you're taking a cut, you can you know, just adjust the speed to suit. Now this machine has a factory option, special option of a back gear mechanism, which is this little plate down here. The original one was removed back in 1985, and this is what I've reinvented it and put it back. It seems to be right. It reduces it from 125 to 40, so it's worth having. Now, as I say, the electronic drive, variable drive for the carriage. I need it running for this, unfortunately. I can adjust the speed there. As I was saying in the previous clip, if you operate both clutches at the same time, it will turn a perfect 45 degrees. I'm saying that is variable, of course, by just slowing it all down. Just switch that off so that will give a bit more. Now this has got a UK MDRO unit fitted. It's only been fitted fairly recently. I mean, the main reason for it is that this is I was getting work into which was a bit more metric, and of course keep converting from one to the other. It's a bit of a bind, whereas this is quite nice for the DRO. Now the other feature that caused me a problem is that this is what is known as a direct drive dial. The lead screw is a 100th hour pitch, but the graduations on the dial are 200. So when you're actually turning something, you haven't got to fiddle arse with you know how much more to take off. You've got to divide it by 2. So if you mic something up and you need to say, okay, it needs another 80th hour off, well, you just put 80 on here and away we go. But the biggest problem was that it used to catch me out. It's lovely. I wouldn't like to go back to an ordinary conventional lathe, all this keep dividing by 2 lot. But the problem I came up against was either screw cutting or doing circlip grooves. Because usually when you look at the chart, say for argument's sake, oh, it's thread depth is 45 thou. Well, you had to remember to put 90 on here, otherwise it didn't come out right. But what's a nice feature of this DRO is it's got a radius or a diameter function, so I can overcome it by that way. Now the DRO, when I purchased it, I got magnetic scales. As I say, now just wind this along. And I managed to fit it behind the saddle. There's a magnetic scale, 5 microns for the carriage, and the reed head is just here. But for the cross slide, we can get into there for you. Move that out. Oh dear, move that out of the way. I bought the 1 micron scale. So as I say, it's very useful. I said I've only had it a couple of years now, but I certainly wouldn't do without it now. What other features are there on there? Oh, of course, it's got the because it's come from Phillips. It's got a genuine Swiss multi-fix tool post, and of course, and up there, of course, all my assortment of holders and things. Now, hiding under this black plastic bag is to keep all the rubbish off it. Is a taper turning attachment. It's not a genuine Hardinge one, but it's one that with a slight modification fitted no problem at all. Now, although this lathe came equipped with a flood coolant pump, I don't use it because it don't use coolant enough to justify filling the tank up, and of course it tends to go all nasty and smelly. So what I've actually bought is a just stuck up under here. This is a Noga Mister, and what I've actually got down there is a 3 litre, yeah, 3 litre I think, metal bottle with the coolant already mixed up. So when I need to use it, it's just a case of because it's on a magnet. I can just stick that on there and away we go. Just turn it on. Just uses a very small amount of compressed air, so it's not it's not going to cost you an arm or leg to run it in air. Well, here we are. This is just a distance shot to sort of finish off with. Can't say much else about it. I say it's certainly a super lathe. I have no regrets on getting it. So all that we need to do now is about 3 paces to the left again, up into the far corner, and that will take us on to machine number 5. I'll meet you there. So here we are. This is right up in the far right hand corner. Can't go any further other than the door out into the garden. This is machine number 5, which is my Deckel SO single lip tool and cutter grinder. Now this is, I acquired this at the same time as the Hardinge lathe when we did the when the company did a downsizing. Now for once I'm actually I'm ahead on this on YouTube. I mean I've had this long before Blondie Hex acquired her one, and Stephen Gottswinter and Robin Renzetti acquired their Chinese clones. So at least this time I'm ahead of those. It comes with a built-in dust extractor. If we can get around there, which is this unit. As I say, it's 3-phase. I'll turn it on and give you a whir, a bit going, so you can hear it. Then the sucking noise is the blower. The dust gets sucked up through this pipe and into that unit there. So just knock that off. Oh. Aluminium wheel at the moment, but I do have diamond cut wheels, so you know I use it a reasonable amount. I mean it's mainly, I mean I've got no engraving machine or anything, but you know it's certainly handy for sharpening D bits and things like that. So it's a well worth if you've got the room and you can and something comes up, you know, one crops up, go for it. It's certainly worth having. Now from here, the only next move is to say we're right up the far right hand side of the garage, is to go across to the other side, and I will pan around and show you that. And there we are. There's the other side, and that's the door to the house. Now that is my surface grinder. It's well documented. There's 3 other videos at least. So if you haven't seen it before, go back to the my playlist and it'll tell you all about it. Right, let's move on to what is hiding behind the cutter grinder. Sorry, the surface cutter grinder, idiot. Surface grinder. Well, here we are, machine number 7. This is an English-made Meddings pillar drill. As you can see, painted in the Phillips blue that's got a funny green. 3-phase machine, forward and reverse, 4-speed, 4-step pulley with high and low gearbox. The table is raised and lowered with a rack and pinion, and it's also got fitted a one of these easy clamping devices. It's you just lift that up. See that at the moment. This is easy to move. Simply just pulling that down with the cam. Yeah, see, she don't move at all. Yes, we had to have those fitted as in England in the workshop. It was part of the health and safety at the time. Down on the floor, if you can make out in that black dustbin bag, that is one of these old cheapo Chinese 3-in-1 machines. It's you know, it's a guillotine, it's a bender, it's a roller, and that's the 12-inch version. I'll pan around a bit under the bench. So behind all those G clamps and things, that is my new air compressor under there. And now moving up onto the top of the bench, there's one of these again cheapy Chinese belt sanders with a sanding disc on the end. Now this here is a professional drill sharpener. It takes multi-size. There's the multi-size collets, and what you actually do is you fit this. Your drill goes into into here. And once you've put it in here and set it to the right orientation, you then put it in the lower hole and grind the drill. And then if you want what they call the split point, which extends it down, you then actually then put it into the top. Alongside it is a almost finished. Sorry, I've got the microphone lead caught. Yeah, alongside it is an almost finished stent tool and cutter grinder. It was a set of castings. I started building this in the UK. I mean, I started this probably, well, I don't know. Well, I've been in Australia 20 years, so it goes to show. Yeah, a set of castings sold by Blackgate's Engineering. But to be honest, I doubt if I shall ever use it, because I say I'm 72 years old now, and I've got a drawer full of end mills and things, to say, and time's more important than you know, my time of life. So, you know, if straight away and buy a new one rather than spend hours and hours trying to grind it, and then it may not work or not. Then finally, moving forward here is I've got a Bosch offhand grinder, you know, finer course wheels. Now, what you're seeing now is another one of Dave's YouTube follies. This is what is commonly known as either a shadow graph or a profile projector. I see several people on YouTube had one. I mean, Mr. Crispin in the UK has got one, Mr. Pete in the USA has got one, and Robin Renzetti has just recently refurbished one. So I thought, well, if it's good enough for YouTube, it's good enough for Davey. But as I say, I've bought it, but never used it yet. I mean, the idea is oh, so we have to try and get that on there. I don't know if you make out there. That's the profile of a thread chaser. And the idea is that if you actually want to measure something, you can if you've got the outline, you know, as a slide, you can compare it to that, or you can actually measure the stage down here. Normally there's a micrometer in here and in here, but I've not bothered to. I've taken them out for storage. But the stage actually slides, and as you can see, as it stage moves, so does the shadow. And by the use of the micrometer, you could actually, if you wanted to, measure, you know, what the pitch of these is. Not much else more to say than that, really. As I say, it's sitting here gathering dust, but I might find something to use for it one day. But as I say, Dave's folly. Just put it down to right. We now come onto the bench area. As you can see, it's quite a long bench. It's a 2 metre odd bench. It's got 3 steel drawers underneath, you know, filled with files and spanners and all the rest of it. And beyond that panel below is a storage area for all my materials. On it is a AC/DC TIG welder, which I don't use too often, but I just thought, well, it's nice to have. Now, I don't know whether we can actually make out in the background. Not really, but anyway. But there's a behind, yeah, just here. That's a that's the Argon cylinder. Now, I don't know whether they've changed it, but in the UK 20 years ago, the only way you could get gas was either air products or BOC, and you had to have a yearly rental on the cylinder. Well, it used to cost you an arm and a leg, so you know, that was out the window. But here in Australia, you actually put a deposit on the bottle. It's $200 for the bottle, which is returnable at any time, and plus $90 odd for the gas. So I've also got Oxford settling the same. So all that you do is each time when it's empty, you take it back there, and they swap it over for a full one. So at least it's a decent, you know, you can get your money back. Whereas the old VOC way was, you know, it was money down the drain, really. Now this alongside it is a tapping machine, made from castings, you know, sold in the UK, and they say it takes ER 20 collets. the original design was a plain spindle with a small Jacob's chuck on the end, but I thought, well, this is much better, because you say you can you can put different size taps in it. So instead it's sprung loaded as well, so that you can you put your job. But at least this way you're ending up with the tap nice and square, none of this through on the wonk. Moving along, we got this here under this bit of junk is a granite surface plate. Here is a cast iron surface plate, and this, what you're seeing here, is a slow grinder. It's a Stefan Gottswinter in Germany made one, and this is a sort of a copy of his one, but with improvements. It's got it uses standard diamond discs, that you buy from China, and they're held on with magnets. Won't go into any more detail, because what I've actually done was I made a second one of these and actually sent it to Mr. Crispin in the UK, and he's threatened somewhere when he gets around to it, amongst all his other videos, to actually make a video on it on how to use it. And of course we got the dear old trusty bench vise. If I move back a bit, we got all the usual these boxes here contain they're all labelled up, all the different taps and dies, Allen keys, and all the moving along, and all the different drill indexes, and on the shelf above, BA screws, metric screws, spare odds and sods all up the top. Well, that brings us to the end of this part of the tour, but don't go away, because we now need to move outside to the garden annex to see what other machinery I've got outside. So follow me outside, and we'll see what else I can show you. Now, what you're seeing here is one of these cheapy Chinese bandsaws. This is a 6x5, I believe. I've done several modifications to it. I've added here a half round section of PVC pipe to collect all the swallows, because usually it just drops through from the blade straight onto the shelf below or onto the ground. The other feature I've added is down here is a car scissors lift. As you may well realise, you have to lift the front up to move this, though it's got wheels at the back. It's quite heavy, and I've had a recent hernia operation, so I've actually fitted this. So what I actually do is just wind it up until the front feet clear the ground, the back wheels touch the ground, and I'm able to move it. But obviously once it's in position, I'll lower this back down again to make it stable. Now, the other main modification I've done is to do away with the crappy spring mechanism that they had on it, and fitted a hydraulic lowering unit. Now, this is what you see here. This is the Mark II. The first version, I copied what a lot of people on YouTube have done, and that's use a pneumatic cylinder and only put oil in one side of the cylinder. I had terrible trouble with that. There was no sear on the ram end, and I kept losing oil, so I bit the bullet, and actually this is a double acting professional hydraulic cylinder off a tractor. And what I actually did with this one is make the oil in both ends of the cylinder. Now the oil in the non-ram end is a greater quantity than what the oil is displaced in the ram end. So to overcome that, I've added this little tank here, and that collects the surplus oil. Now, the operation of this is it has a non-return valve in there. So and just here, this is a stop valve, and this is a needle control valve. Needle valves to control the amount of speed that it comes down, and also there is an optional pressure gauge. That's quite useful, really. It's so worked that I can actually instantly raise the the head up. I'll just make sure that's shut for a minute. I'll just raise this up a bit, and by shutting this valve here it'll ensure that the blade remains in the up position for as long as you want it to be while you're adjusting the material, measuring, etc. Then when you're ready, you can open this valve here, and then slowly adjust the, and as we can see at the moment, see there's something like about, I don't know, 160 psi on it. That's the pressure exerted from the ram. But by opening the needle valve, as you see, that drops about 60, and if we get up there, the blade is slowly descending, and by adjusting the needle valve I can control at what speed the blade cuts. Ideal cutting pressure shown on this valve is somewhere around about the 60 pound mark. Very pleased with the system. The only slight drawback that I come across, this being a proper professional hydraulic ram with a ram seal, is that the friction on there is quite a bit, and this standard arm wasn't enough to overcome to allow it to function. So what I had to do was to purchase some fixed 4 2.5 kilo keep fit weights on it, and that allows it to function. A little bit of a nuisance, because because now to lift this arm I've got to lift the arm and an additional 10 kilos, but as I say, it's not used very often, so you know, not too much of a problem. Now the other thing that you can do with this saw is to put it in an upright position, and here, just there, they provide a little sub table that you can fit on there and actually use it as a vertical bandsaw. I've never used this because, as you'll see in a minute behind me, I've got a dual 12/16 contouring bandsaw. So there we are. Just pan back a bit and give you another sort of final little look at it. Hope you found that of some interest. If you want any more information, as I say, drop me an email and I'll you know, I can give you some more information if you actually want to do the hydraulic circuitry. Right, let's now proceed to the other annex, and we'll view the final remaining tools. See you there. So what you're now seeing here are the final 3 machines that I have. Is the dual bandsaw, a sandblaster, and a lineager. We'll move in a bit closer, and so that we can have a look. Now under this this red item in the plastic bag is one of these cheapy Chinese bench mounted sandblast units, but as you've seen earlier, I haven't got much bench space, so this is mounted on wheels and stored here under the bandsaw. Now this bandsaw, there's several other videos of it being rebuilt, so you know, if you haven't seen it before, go back and have a check. Now this unit actually arrived with this plate, which is the clamping plate for a rip fence, but unfortunately the rip fence didn't come with it, so I inquired to purchase one. They want $1,500 from the USA plus shipping, and the biggest drawback is that the guide, the rip fence, the length of the rip fence only goes up as far as the front of the blade, because what happens is it slides on, goes sideways, and is clamped on, and I thought that's no good for me. I mean, for 2 reasons. I mean, firstly, that I didn't want to spend that sort of money, and secondly, I really wanted it to go past the blade. So what you're actually now looking at here is this is what I manufactured myself. It's made out of 1 inch by 4 aluminium, or as you Americans say, aluminum, and it's all bolted and doweled together. My idea is what I've actually done is here there is 3 pins that that push out, and then it then clamps from the bottom. So I'll show you about fitting that on. I'm sorry I'm having to do this a bit one-handed, but anyway, so what we actually do is we slide it on from the front like that. I put my finger underneath and pop up those 3 pins. That then keeps it square, doesn't move, but I'm allowed to slide it, and then whenever I want to I just tighten this clamp, and there we are, we've got a rip fence. As I say, you see it goes, I don't know, 3 odd inches past the blade. And also this is I put a stainless steel strip on here, you know, because otherwise, you know, the aluminium would have got chewed up, you know, rubbing lumps of rough metal about it against it. As I say, it's a fully working machine. It's got a fully working blade welder. And what else has happened? Oh, I've added down the bottom here. There's a normally there's an open box there that all the swab drops into, but this is a sealed box that actually it's got a shop vac on it. I'll give you a little whir of it running. Oh, well, this here on the side is an air pump, you know, for blowing the chips off, and I've also fitted a USB light. Okay, there we are. They're just coming in. Anyway, I'll give her a run for you. Let's say it's variable speed, but of course I can't get it at the moment to change the. So it's a little bit awkward, say, because the handle for changing the speed is right around the other side. As I say, what we've actually got here is they call it a 12/16, so it's 12 inches deep. You can get 12 inches here and 16 inches between the blade and that column over there. Yeah. Oh, and by the way, John, in Scotland, if you happen to be watching this, note there isn't a big hole behind the blade for your just for your amusement. Over and out. It's also got hydraulics on it for. Inside there's a weighted mechanism that you can control with hydraulics for when you were cutting. But years ago, before we had all this plasma cutting and laser cutting and things, that you know, if you wanted to cut something out as a contour, you had to use a bandsaw. And you know, when you're cutting through very thick metal, you know, you haven't got the pressure with your hands. So there's a chain that used to go right around the work and was controlled by this hydraulic function. Now the last machine that we come to here, and where we can make that, because the trouble is it's a bit yeah, it's sunshine, I'm sorry to say. It's what was that? It come from England, of course. Here on Mr. Phillips again, and of course I'm painted in the Phillips blue. But it's what was called back then, back in the 50s, a band facer. But I mean today you would call it probably a, I don't know, a belt finisher. Originally the belt mechanism fitted horizontally on here, so of course it was a real curse, because if you wanted to work a radius or anything, you couldn't you know, to bend your head sideways. So I made this mechanism up, you know, welded up a plate and then brought the motor out, and the whole thing is just sitting on the cabinet. Very useful. I use this a hell of a lot. I mean, it used to be in the workshop where the Bridgeport clone is now, but of course I had to move it out here. That's why you saw earlier I have one of those cheapy Chinese little 1-inch belt sanders just on the bench, so that, you know, if I wanted just to knock a burr off or shorten a screw, I didn't have to come out here in the dark or in the rain or what it was to open up and do it on here. Anyway, I'll give it a little run for you. It's a little bit noisy. So there we are. So this now concludes the tour of you've seen all my machinery. But if you'd like to follow me back inside, we'll conclude this and start the slideshow. There's going to be quite a long slideshow at the end of this. So if you'd like to follow me and we'll head back inside. Oh, and by the way, please feel free to visit the gift shop on your way out. You know, and buy a little memento of your visit here today. Thanks very much. We'll see you inside in a few minutes. Hello and welcome back. Did we lose anybody on the way? No, that's good. That's it. Right, well, I hope you enjoyed that. If you did, please tell your friends. There now follows a quite an extensive free slideshow showing the you know, from the start, you know, moving the machinery out from England out to here, and there's various other pieces of equipment that I've made, and showing close-up pictures of the machine modifications that you've already seen in the video. So all that really needs to be said now is thanks for coming, thanks for watching. Feel free to subscribe, click the bell, click the likes, send me a comment, write me a comment, send me an email, and the email's in the description below. So other than that, it's just a case of saying, wherever you are in the world, please stay safe and well, and don't forget to stop for the slideshow, which will be beginning now.